everyone, I am Dr. Sharmisha Banerjee. Today I will be taking lecture number 2 of the course on fundamentals of computational biology entitled What are models? In the last lecture we have learned the introduction to computational biology, few biological terms like DNA, RNA, what are cells, what are the microorganisms, how their growth curve is related, all this we are going to study in the particular subject, and few things we have just got a glimpse of it. So, these biological terms are very much essential to study, and also in the last lecture we have learned the scopes and applications of computational biology. In the next 30 minutes, we will embark on an exciting journey to explore various modeling techniques and their significance in different fields. Models are indispensable tools used to simplify the complex systems like which we cannot study naturally. For that reason, these models are basically developed or designed. These models are used to predict outcomes and gain certain valuable insights. To kickstart our discussion, let us define what models are and why they matter. It is one of the most important, or we can say fundamental tools that we are going to study in computational biology. A model is a simplified representation of real world objects, systems or processes. Like as we heard the name model, then several other examples comes in our mind. Like a model can be replica of a larger object, or it can be scaled down of the physical world, or we can even relate it to the models who do the ramp walk on the stage. So, these all are basically models. Model basically means representation of certain things, certain objects, certain processes, it can be anything. It aims to capture the essential features and relationships of the subject being studied. Models play a vital role in scientific research, engineering, economics and countless other domains it can be applied. There are various varied application of these models. So, it is very important to learn how they can be created. It also helps us in understanding, analyzing and making informed decision about any complex phenomena. In general context, models can refer to various representations of real world systems, processes, concepts, problems and many more. This is a pictorial representation which indicates how the models can be classified. So, the models can be classified in three major categories based on this picture. The first one is mathematical model, second one is physical and the third one is computer or computational model. Mathematical models can further be subdivided into dynamic and static. Similarly, the physical and computational model can also be categorized in these two forms itself. Then these mathematical dynamic models can again be classified into nonlinear and linear, whereas the static mathematical models can again be further classified into same, that is nonlinear and linear. Again, the nonlinear dynamic models can be classified into two, unstable and stable. Similarly, the linear dynamic mathematical models can again be classified into unstable and stable. Now, the question is, we will discuss in brief what we understand by linear, nonlinear, stable, unstable, dynamic and static models. So, coming with the linear models are mathematical representation that assume a linear relationship between the input features and the target variables. Linear relationship means it will increase linearly, it will increase gradually with respect to time or with respect to the any other independent variable. In other words, here the output is a linear combination of the input features, which is possibly modified by some coefficients. Like these coefficients can be growth constant, these coefficient can be any other constant. So, it can be replaced by mu, rho, alpha, beta and there are many more coefficients like this. Linear models are simple, interpretable and often works well when the relationship between the variables are approximately linear. Non-linear models capture the complex relationship that cannot be adequately represented using linear combination of features, means they do not form a straight line pattern, or they do not form a pattern of y is equal to mx plus c. That means where we have a gradual slope or an intercept. These does not follow those type of patterns. These models account for more intricate patterns and interactions in the data. Static models describe systems at a single point in time without considering the changes over time. These models assume that the relationship between the variables remain constant throughout the analysis. From the name itself, that is, it is static. So, at a single point of time we are going to analyze these systems. But in other words, what are dynamic models? These models, they capture the changes over time or over an instant of time continuously. It allows the analysis of how variables evolve and interact with one another, or we can say how these variables are interdependent or linked with one another. These models are suitable for situations where the relationships between variables vary over time. A stable model is one where the behavior of the system is represented by the model and it remains bounded and converges to a certain state or equilibrium point over time. In other words, small perturbations or disturbances in the system's initial conditions or inputs do not lead to any drastic or uncontrollable changes in the system behavior. Basically, in this type of models, the changes which occurs, they occur in a controlled manner, or the input variables have full control over the output variables or over the output features, we can say. Stability is a desirable property in many applications because it ensures that the system's responses are predictable and manageable. In stable models, the output of the system does not grow uncontrollably or oscillate wildly. That is, here there is no random oscillations. They oscillate in a specific pattern, we can say. Unstable models. An unstable model is one where even small perturbations or small changes or small disturbances can lead to a dramatic and unpredictable changes in the system's behavior over time. That is, a very small change in the behavior, a very small change in the input can lead to a drastic change in the output feature in case of unstable model. From the name itself, these models are unstable. The unstable model can result in divergent or oscillatory behaviors that are difficult to control or predict. Unstable behavior is generally undesirable and it can lead to even system failure. Instability in control systems or unpredictable outcomes in various applications. Understanding the distinctions between linear, nonlinear, dynamic, static as well as stable or unstable is very crucial for selecting the which type of model has to be used for any specific problem. Linear models are simpler and they work well when relationships are roughly linear, while non-linear models capture more complex interactions. Static models, they describe systems at a single point in time, while dynamic models, they account for changes and interaction over continuous point of time. The choice between these models depends on the nature of your data which you are going to analyze and the objective of your analysis or prediction task. Understanding whether a model or system is stable or unstable is very much crucial for making any decision, prediction or for designing any control system and ensuring the reliability of various applications. Stable models exhibit bounded and convergent behavior, while unstable models display unpredictable and potentially divergent behavior. The stability analysis of a system or model is a fundamental consideration in fields such as engineering, physics, economics, etc. There are various types of models which are designed for specific purposes, and here we are going to explore some of the most common ones. The first one is conceptual models. These are simple, high level representations that help in grasping the fundamental aspects of a system. They provide a starting point for further analysis. Conceptual models are simplified representations which are used to convey abstract ideas, relationships or structures. They help in understanding the complex systems or theories. Then the next one is physical models. These are tangible, that is, we can feel, we can touch them, and they can be scaled down. They are basically the smaller representation of the real objects or systems. They are commonly used in engineering, architecture, and are used to design or study the prototypes before building the full scale versions. Like when we visit Taj Mahal, as a memory we used to take a small miniature form of that monument. So, that is basically an example of physical model, we can say. Physical replicas or simulations of real world objects are used for experimentation or testing purposes. Example includes scale models of buildings or wind tunnel testing in aerodynamics. Mathematical models, they are used to correlate the mathematical equations, formulas and algorithms, and basically used for describing and predicting the behavior of system in various disciplines like physics, engineering, economics and even biology. So, here what we have to keep in mind, like which models we are going to focus on their usage in biology. This is our main objective, as we are going to study the course fundamentals of computational biology. So, we have to keep in mind which models are to be used further in designing or understanding the various biological processes. So, these mathematical models, they use, from the name itself, they will be using mathematical equations to describe the relationship between different variables and for predicting the outcomes. Then the next one is computational models. Again, it is very important for our subject, for our course. Advanced simulation run on computers, often involving complex algorithms to model the integrate systems. These models are commonly used in climate science, fluid dynamics and artificial intelligence. Computer models, they are again simulations which are created on computers to represent real world scenarios. Statistical models, these models use statistical techniques to analyze the data and infer relationship between variables and also for making predictions. They help in identifying patterns, trends and correlating the data. They find application in many fields like healthcare, finance and social sciences. Then the next type of model is agent based model. Agent based model simulate individual agents and their interactions to understand the emergent behavior of a complex system, often used in social sciences as well as in ecology. Then the next one is machine learning models, which is of demand of today's world. We can say, we hear AI, that is artificial intelligence. Again, it is use of artificial intelligence or machine learning models to study the complex systems, or even we can say the use of machine learning models in AI and vice versa as well. So, these machine learning models are basically algorithms that learn patterns and relationships in data to make predictions or decisions without explicit programming. Simulation models, they mimic the real world processes or systems over time to study their behavior under different conditions. They are used in various domains like engineering, medicine and economics. Then the next one is cognitive model. It represents the mental processes and decision making mechanisms in psychology and cognitive science. Economic models. It depicts economic relationships and behavior to analyze economic systems, make forecasts and inform the policy decisions or decision makers. Climate models. From the name itself, it is used to simulate and study the Earth's climate system, predicting future climate scenarios and understanding the climate change. Next one is biological models. It represents biological systems and processes such as cell signaling, protein folding and gene regulation. Financial models are used in finance and investment to forecast future financial performance, evaluate risk and make investment decisions like in stock market. Then the next one is educational models. These are the frameworks which are used in teaching and learning process, or you can say for pedagogy, to guide the instructional strategies and curriculum development. There are a few examples of the diverse range of models that are used across the different fields. These models serve as a valuable tools for understanding the complex systems, making predictions and improving the decision making processes. The choice of the model type depends on the specific problem, the availability of the data, what type of data are with us, and the level of the detail which is required to address the research question or problem at hand. Then what are the objectives of model building? There are many objectives. First one is defining the boundaries, or we can say defining the extremities, defining the limits. The second objective is for identifying the key variables, like which factors are influencing this particular process, design or system. Identifying the key structural drivers, that is which will speed up the particular process or which will enhance the design of a particular process or improve the quality of a particular process. Then the next one is evaluating the availability of data, and the last objective is identifying the key policy levers and interventions. Then in short, we will study what is the modeling processes or what are the steps involved in modeling. One by one, these are in bullet forms. The first one is definition of the problem or defining the boundaries. What is it? I will deal in the next slide. Formulation of dynamic assumptions, creation of a simulation model, validating the model, and ultimately formulation and evaluation of policies. Now let's delve into the key steps that are involved in creating a model. The first one just now I discussed was problem definition or defining the problem. Here we need to clearly define the purpose and scope of the model which it is to be used. What are we trying to achieve and what variables are crucial to consider. Clearly articulate the problem you want the model to solve. So this is a very important step. Designing the model or defining the problem itself solves many of the issues or gives solution to many of the problems. So we need to define our problem very clearly. We need to identify the variables or the crucial factors that are going to impact this particular model. This involves understanding the business or research question, defining the objectives and deciding the type of the model that will best fit the problem. Example, classification model is to be used or regression is to be done or clustering, and it can be many more like so on. Next is data collection. Models rely on data to be accurate and reliable. The food, or you can say the ultimate factor which decides how the model will work or which decides the training of the model is basically the data. So these data needs to be properly collected and validated. It is the foundation of a robust model. Gather the relevant data that will be used to train as well as test the model. The data should be representative of the problem domain and also of good quality, like the data should be segregative in nature. If I am dealing with a problem I cannot be focused on a particular region, or I cannot be focused for or biased for a particular type of condition. I need to clearly collect the data from different places, from different regions, depending on our scenario, depending on our problem. Like when we check in our daily life, if we check how the rice is cooked. So, I am not picking the rice from any particular domain or any particular area, I am randomly picking. So, the data collection has to be random, and it is to be the representation of the original problem, representation of the original population, I can say. Then the next step is assumptions. Again it is a very important step, like we need to assume what is the condition or what factors will be actually static, which all will be dynamic, and how they will be influencing. So, this is again a very important step. All models involve simplification and assumptions about the real world. It is important to identify and acknowledge these assumptions to interpret the model's result accurately. Then the next one is data pre-processing. We cannot work on the whole collected data, or we cannot work on the raw data, it needs to be pre-processed. In some case the filters are to be used. So, data pre-processing is required. Preparing the data for modeling by cleaning, transforming and organizing, or we can say by filtering or sorting it depending on our need, depending on our requirement. This step includes handling the missing values, dealing with outliers and encoding the categorical variables. This is just simple how we do the statistical data analysis. Likewise, here also we need to remove the outliers. Then the next one is which feature needs to be selected, it has to be fixed. Feature selection or extraction from this whole world of data, from this whole vast world of data, we need to extract which is required for our study, which is required for our model designing process. So, we need to identify the most relevant features, that is the input variables that will be used to train the model. Before the model works, or before the creation of a model, this model needs to be trained in a particular way. In some case, the feature extraction techniques may be applied to derive more meaningful features from the existing ones. Splitting the data. Divide the data set into 2 or 3 subsets, a training set, a validation set which is optional, and the last one is test set. Every data needs to be further splitted or divided into compulsorily 2 sets. It can be 3 or many in some cases depending on the need. The training set is used to train the model. The validation set is used to tune hyperparameters. I will talk what are these hyperparameters in next slide. And the test set is used to evaluate the model's performance. Basically, hyperparameter tuning or tuning of hyperparameter is preparing the model with the help of AI tools. Then the next one is model selection. Choose the appropriate model algorithm for the problem at hand. This could involve selecting from various machine learning algorithms, statistical models or deep learning architectures. Like we will generate 3 to 4 models for a particular system, but which one is best fitting our work, best fitting our study, it needs to be decided here itself. So, choosing the appropriate type of model and formulating the mathematical or computational representation based on the problem at hand is done at this particular step. Then the training of the model, again it is very important. We are using the training data to fit the chosen model. Based on the training itself, the model will work, the model will be evaluated further. So, what is done at this particular step? During training, the model learns the underlying patterns and relationships in the data. Hyperparameter tuning, many models have hyperparameters that needs to be set before training. Hyperparameter tuning involves finding the best combination of hyperparameters to optimize the model's performance on the validation set. Then the next step is model evaluation. Assess the model's performance using the test set. Training set is utilized in the above step. Then the test data set is to be used for evaluating the model. Fine tuning the model using historical data and validating its performance against real world observations. Common evaluation metrics vary based on the type of the problem, such as accuracy, precision, recall, F1 score for classification, or mean squared error, that is MSE, for regression. Model validation, calibration and iteration is the next step. Like if the model does not perform well or does not perform satisfactorily according to our need, or it is not able to solve the problem which we articulate, then what needs to be done? Then we need to revisit the previous step, such as data pre-processing, feature selection or hyperparameter tuning to improve the model's performance. It is again very important. Then the next or the last step is model deployment. Once you have a model that meets your requirement, deploy it to a production environment where it can make predictions on new unseen data based on the training what we have given to this particular model using the training set data. Then the next one is model monitoring and maintenance. That will be a continuous process and it will be monitored continuously with the real world environment, and this step is again very important to improve the model which has already been designed for any particular situation or circumstance. Continuously monitoring the model's performance in the real world environment and periodically retrain or update it as needed to maintain its effectiveness. Remember that model regeneration is an iterative process and it may involve several times going back and forth between these steps to fine tune the model and achieve the desired results. The process can vary depending on the complexity of the problem, the available data and the chosen modeling techniques. Then how these models can be applied in various fields. What are the various applications? These are the versatile tools with countless applications, but let us explore some of the most impactful uses. The first one is prediction and forecasting. Models can be used to predict future outcomes based on the historical data. They can be used to forecast future trends from weather predictions to stock market analysis. For example, weather forecasting models predict the weather for the coming days based on past weather patterns. Regression analysis models can help establish relationships between variables and make countless predictions. Or continuous predictions. Regression models are commonly used in finance, economics and other fields to predict numerical values such as stock prices, sales or sale figures. Decision making models aid in making informed decisions by analyzing various scenarios and their potential outcomes. Image and speech recognition models can be trained to recognize patterns and features in images or audio data. Image recognition models are used in facial recognition, autonomous vehicles and medical imaging analysis. Scientific understanding models support scientific theories and aid researchers in understanding complex phenomena like the behavior of particles or the spread of any infectious diseases. Clustering models can group similar data together based on certain features. Clustering models are used in customer segmentation and anomaly detection among other applications. Optimization models can be used to optimize processes or systems by finding the best possible solution to a problem. For example, optimization models are used in supply chain management to minimize transportation cost. Recommendation systems models can provide personalized recommendations to users based on their preferences and behaviors. Like when we open the Myntra store, the size is automatically recommended if it asks whether you are purchasing it for you or whether you are purchasing it for someone else. Based on the history of your order, it recommends that this particular customer needs size L or size M. So, recommendation systems are commonly used in online platforms such as Netflix, Amazon to suggest movies or products, just now I discussed. Then the next one is, these are also applied for simulations. Models can simulate, or it can correlate, or it can create an exact world of the real world scenarios to understand the behavior of complex systems or to train individual in a risk free environment. For example, flight simulators are used to train pilots. Just now we have recently watched a movie where the same simulation has been produced, how the landing of a flight can be done, to track whether the accident which occurred was natural or it occurred unintentionally. Then the next one is natural language processing. Models can process and understand human language, enabling applications such as chatbots, segment analysis and language translation. Risk assessment. Models can assess risk in various domains such as finance, insurance, healthcare, and much informed decisions can be taken beforehand, and it reduces the potential negative outcomes. In fields like insurance and finance, models help assess risk and uncertainties. Gaming and entertainment. Models are used in creating artificial intelligence opponents in games and generating lifelike characters or animations. Biological and environmental modeling. Models are employed to study ecosystems, population dynamics and climate change, helping researchers and policy makers understand the complex environmental phenomena. It can also be applied in drug discovery. Models are used in pharmaceutical researchers to simulate the behavior of molecules and identify the lead candidates or the potential drug candidates. Next, it can be used for process control. It can be used to monitor and control industrial processes to optimize their efficiency and ensure safety. These are just a few examples of the vast range of applications for models. Models play a crucial role in decision making, problem solving, gaining insights in almost every domain from business and engineering to healthcare as well as social science. The application is much more varied than we can even imagine. Challenges and limitations. Despite their benefits, models also comes with challenges and limitations. Some of these include simplification. The need to simplify complex system can lead to oversights or inaccurate representations. The second challenge will be data limitation, like in some cases data are not that easily available. So, models heavily rely on data and incomplete or biased data can affect their accuracy. Uncertainty. All models have certain uncertainties and it is very crucial to acknowledge the level of uncertainty in their prediction. Like when we take measurement from even any equipment, there is a least count of the equipment, or there is a calibration point, or there is a accuracy, there is a sensitivity, there is a reproducibility. Similarly, these models also have some sort of uncertainty or inaccuracies that needs to be described beforehand itself. Overfitting. In predictive model, there is a risk of overfitting the model to historical data, leading to poor generalization to new data. In conclusion, models are invaluable tools that enable us to comprehend the world around us and make well informed decisions. They come in various types, each with specific applications and limitations. As you continue your journey in various fields, always keep in mind the power and responsibility that come with creating and utilizing these models. Thank you for joining me in this exploration of models. I hope it sparks your curiosity to learn more and apply these powerful tools to solve the real world challenges. In the subsequent lectures, we will be learning the application of these models in few biological experiments like Lotka-Volterra model or growth models, or the spread of cancer or the spread of any infectious diseases like COVID. Thank you.